Uh, Welcome to the session. Now we are going to see about state elimination technique problem. Using state elimination technique, we have to find the regular expression for the finite automata. So here we'll have this problem. The problem given here is states and 0 and 1 transition on that. Q1 on 0 it goes to Q2, Q1 on 1 it goes to Q1, Q2 on 0 it goes to Q3, Q2 on 1 it goes to Q1, Q3 on 0 it goes to Q3, Q3 on 1 it goes to Q2, and Q1 is a start state and Q3 is a final state here. And for this the transition diagram is looking like this. Using this transition diagram, and we have to follow these rules as we discussed in a previous video. We'll have to solve this problem, right? So when we see this kind of problem, we have to be eliminated intermediate state. So when you're looking at this diagram, so Q2 is an intermediate state. We need to eliminate this Q2. So after this, when you have this regular expression, only the start state and final state for should be needed for the regular expression, final regular expression. So the only thing we need to eliminate is Q2. Okay. So for this, for eliminating this Q2, we have to find the following states. Okay, we have to find the following state of transition. For example, to be found, the step 1 here is to be found. The first one, Q1, Q2, Q3. So this is one of the transition, and we'll have, so we need to concentrate on this Q2, right? And then Q3, Q2, Q1, again Q2, and Q1, Q2, Q1. The fourth one is Q3, Q2, Q1. So when you're looking at this, you need to eliminate this kind of transition. You need to eliminate this Q2 for making this kind of transition. So when you remove this Q2, you have to concentrate, and you have to keep on seeing this kind of transition. Then only we have to completely eliminate this Q2. Okay. So for this, so first you have to take this one, right? So my the step 2 here is you have to take Q1, Q2 and Q3. This is my step 2. So when you step 2 here is, we'll have so here state to eliminate is Q2, right? So we have to draw a diagram. So when you refer this kind of thing, you have to follow this kind of diagram, because only 3 states are available. We need to eliminate this intermediate state called S, and we'll have to keep the both accepting state and the initial state. Okay. So for this, we'll have this one. The formula will be here. Here state to eliminate is here is Q2, right? So for this, we have to follow rule 1. As per rule 1, okay, as per rule 1, regular expression Rij plus Qi exclosure Pj. So this formula will be, we have to use. So when you have this, draw a diagram like this, right? So my Q1 is looking like this, and this will be your Q3, and this is Q2, right? So when you see this diagram, refer this one, and you have to make this diagram as the prescribed way. Okay. So you see here Q1 on 1 it stays self loop, and we'll have this one q1 on 0 it goes to q2, right? And q2 for q3 it is uses 0 to move that, and we'll have 0, right? Okay, so there is no s for this as per diagram. So now, so see here, when you're looking at this diagram, and you have to equivalently written as a rule 1, right? Okay, fine. So here there is no rij, which means you have q3 to no q1 to q3 there is no edges is going on, so just leave it. So this is phi, and here this is known as qi, and this is pj and s. So s is also phi, right? So phi closure, and so qi is 0, this is phi closure, there is no s, that's why it's phi closure, and pj is 0. So when you have this, right, so 0 phi closure is epsilon, right? So when you see this epsilon, so epsilon into 0, so epsilon into r equal to r. So 5 plus 0 0, so epsilon, so 5 plus r equal to r only, so you will have this 0 0. So for this regular expression which is known as r1, say it is r1, so r1 is 0 0. Okay, so for this next combination we need to find is q3 q2 q1. So this is the next one, q3, so this is step 3, right? q3 q2 q1. So q3 q2 q1, so here again we eliminate the state, so eliminate q2, and when we see this diagram, right, after this diagram from q1 to q3 your transition diagram will be looking like this, q1 to q3 we have to write like this. So this is 1 and this is 0, so when you have this, this is 0 0, so q1 to q3. So I forgot to draw this, that's why I'm drawing here. Okay, so after this we'll have this one, so again we have to follow, so this is q3 q2 and q1, right? Okay, so for this one, this is 0 and this is 1 actually. So q3 to q2 this is 1, and q2 to 1, so refer this one here. Okay, and q2 to 1 here it is also 1. Okay, and q3 to, so here q3 is final state, right? And here q3 to q1 there is no more rij, so just leave it, and there is no s's there, so this is qi and this is pj. So when you have this regular expression r2 equal to rij plus qi s closure pj. Okay, what is rij here? So there is this is 5 and qi is 1 and 5 closure, and this is also 1. So when you see this 5 plus 1 1, which is known as 1 1, my r2 will be 1 1. For this, so here this is my r2, so r2 is 1 1. Okay, So after this we have to redraw this diagram like this. So Q3 so when you have this right, Q3 to Q1, so Q3 to Q1 it is 1 1. Okay, for Q3 it is 0 and this is 1. Okay, so this is the thing. Next one is step 4. When you see this step 4, we have to take this one Q1 Q2 Q1. Okay, so Q1 Q2 Q1, so this is also eliminate Q2, so we have to eliminate Q2, right? So when you have this, just refer this diagram, this one. So Q1 will have Q2. So what is Q1? So when self state is 1, and when you see this Q2, Q1 to Q2 it's 0, and when you have this is 1, right? That's it. Okay, so for this we have to use the rule of note. So here only 2 states are available and 1 state we need to eliminate since it's a non-final state. So for this we have to use the formula R plus SU closure T. So for this we'll have this R3 equal to R plus SU closure T. And what is my R here? So when you see this, right, this is RSU and back loop is T. So the same will be followed. For this R, this is 1 and S is 0 and there is no U, which is known as phi closure, and T will be 1. So when you see this 1 plus 0 1. So this is my R3. Okay. 1 plus 0 1. And finally we'll have this step 4, so step 5. So step 5 we need to eliminate Q2 and the transition is Q3 Q2 Q3. So this is not Q1, this is Q3. Okay, so Q3 Q2 Q3. Okay, it is kind of a self loop. So here also we have to eliminate Q2, right? For this we have to see looking back to the transition diagram. So we'll have Q3 and Q2, right? So for this Q3 it is self loop 0 and Q3 to Q2 1 and Q2 to Q3 it's 0 and there is no self loop on that. Just make use the same formula. So when you have this right before, you have to redraw this diagram. Just after this step redraw this diagram, which is known as Q1 Q2 Q1, right? So we have to eliminate this one. So Q1. So for this we'll have 1 plus 0 1. So this is the diagram representation of this transition diagram after eliminating Q2. So here also we'll have this one, right? So R4 equal to R plus SQ closure T. So here R is 0 plus S will be 1 and there is no U closure. Since it is 5, it is 5 closure and T is 0. So when you see this, right, 0 plus 1 0. Okay, this is 0 plus 1 0. So after this we have to redraw this diagram. So after this one we have to redraw it. So this is R4. So Q3. So this one is 0 plus 1 0, right? Okay, so next one is step 6. Combining all the above steps Q1 and Q3. So which is the elimination state is eliminated as Q2, right? So for Q1 the self, see here, for Q1, Q2, Q1 the self state is 1 plus 0 1. So which is to be redrawn 1 plus 0 1. After this Q1 to Q3 will have this state Q1 to Q3, which is known as Q1 to Q3 is 0 0. So right, so it is 0 0. And on Q3 we have the, see here, so Q3, Q2, Q3. So after eliminating Q2, so you have the self loop which is known as 0 plus 1 0. You need to draw this one, 0 plus 1 0. After this Q3 to Q1, right? So Q3 to Q1. So Q3 to Q1. See here, Q3 to Q1, it is 1 1. So just refer and redraw all the steps here. Okay, so as per rule 2, what is our rule 2 says in state elimination technique? So if Q and Q naught such that accepting state and start state are distinct, we have to use the formula here. So my regular expression formula RE equal to R plus S U closure T, the whole closure S U closure, right? So here we'll have regular expression. R here is 1 plus 0 1 plus S 0 0, U closure in the sense 0 plus 1 0 the whole closure, and S again it is 0 0 and 0 plus 1 0 the whole closure. So this is also a whole closure, right? So this is 1 1 the whole closure, 0 0 plus 0 1 0 plus 1 0 the whole closure. So R, so this is my R 1 plus 0 1 plus S 0 0. So this is my R and this is my S. This is U and T, right? S is 0 0 into U closure, 0 plus 1 0 the whole closure, that is U closure, into T. T is 1 1 and we'll have this whole closure. That's why the whole closure. After this into S U closure. S is 0 0 and U closure is 0 plus 1 0 the whole closure. So this is the final answer for this regular for this finite automata after the reduction process of regular expression. So by using state elimination technique we have achieved the regular expression. Okay, see here. Thank you.